I said something about this modulus of complex number and argument of complex number. Arguments. Oh, let's put the date first so we can identify it later. It's Monday. 19th. No. I've explained something, or did I do any example in school? Guys, talk to me, please. Did I do any example in school?
I think you did.
Okay. Did I give you any exercise to do?
I think so.
Okay. Let's see. Oh yeah, we did. Then we also did, oh, we already did arguments, right?
Yeah.
Oh, okay. I thought I haven't taught you arguments.
I thought we only went halfway through.
No, we actually went more than halfway through. Okay, just to be sure, let's do some practice, okay? Let's do some, I'm gonna create different questions now.
Last class, you said we were going to do polar form and we didn't get there yet.
Yes, yeah, polar form of complex number. That was, but without argument, you cannot do polar form. So I'm going to give you 4 different complex numbers. I need you to find the arguments just to be sure, because without arguments, you cannot do polar form of complex number. So everyone begin. Find the arguments of this complex number. If 1. This is 1 plus I, okay? Do not write all the questions before you begin. Just write question 1 and do it. So on WeChat, you send me the solution. You sent to me personally. That's how, I believe you remember how we practice. And for Carolina, that's how the practice is done. Okay? Can Carolina hear me?
Yes.
Okay, great.
Mr. Daniel, should we send them to you question by question or the whole thing at one time?
Question by question is fine. So I don't have to, everybody doesn't have to wait. Question by question is fine. Okay, got something? Correct, Carolina. The first one you sent. Instead of 1/4 pi, you can write it as pi/4.
Okay, thank you.
Yanko, when you draw, where's your Argand diagram? I thought I told you to always draw the Argand diagram.
I forgot. I'm so sorry.
I need to see it, okay? The Argand diagram will tell you if you need to introduce alpha or not. That's how we did it in class. Okay, I need to see the Argand diagram. Otherwise, this may not be correct. And if you look at your question 2, it is √3 minus I, not √3 plus I.
Okay.
Kada, if you look at question 1, that shouldn't be alpha. The angle itself is theta. Alpha is that variable you introduce to find the acute version of it, if it is more than 90, if it is not acute.
Oh, okay. That's
Look at the example that I did, if you don't mind. Okay?
Okay.
Alex, I don't know how you got arctan of 1/2. I don't know where 1/2 come from. And even arctan of 1/2 is not 0.5. So where did you even get that? Besides, 1/2 was never given, Mr. Alex. Please check your number 2 correctly. Number 1 is correct, but then you put degree. It's not degree, it is radian. So that degree notation is an error. Okay, Alex? Good, Carolina, that's correct. Carolina, so you wrote 1/√3 equals minus √3/3. You don't need to rationalize. You don't need that √3/3. Once you write your minus 1/√3, Actually, when you're doing that, you can work with 1/√3. Okay, it's okay the way you did it, but that minus √3/3 part is not necessary. That's my point.
Okay.
Because you're going to put it in the calculator to evaluate anyway, and your calculator is giving you the right stuff. Okay, then the part of minus 1/6 pi is not necessary. Just write your minus pi/6 directly.
Okay.
Elsin, first one saying correct. 1/4 pi is not necessary. Elsin, just write your pi/4. So that line is not necessary.
Okay, thank you.
Your correction makes sense now, Mr. Iron Man. I mean for number 2. Number 2 makes sense. I need to see the Argand diagram because the Argand diagram will tell us what to do. I'm sure you have your notebook. You must have written the example. I haven't seen any question from Kelly. I hope you are not planning on sending me all the 4 questions at once. There's a reason I ask you to send one at a time, and so that I don't have to waste time waiting for others, or others are waiting for me to be done with checking a lot of questions from one person.
No, because I left my Casio calculator at school, so I'm using another calculator, but I don't know how to change it to grad.
You can always use online. Just go online, write scientific calculator in radian measure, and something will pop up. Somebody will have coded something. Everything is online, I'm sure.
Okay.
Mr. Alex, so tan theta is 1/√3. Are you sure it's 1/√3 or minus 1/√3? Alex.
Minus, sorry.
Exactly, minus. In that case, yeah, because remember the z is below y-axis, so it's expected to be negative. That's how you know that you're wrong or something is wrong. Elsin, is this Elsin? Yes. You wrote tan theta is arctan is O/A. Well, in IGCSE class, we expect you to write that. But in IB class, you don't have to write tan theta is O/A. Okay? Because we
just go straight to theta equals
exactly.
arctan.
No, you can go straight into tan, yeah, either theta is equal to arctan or tan theta equals what is O/A. We don't even call them O/A because we are not looking at it as a triangle. That is even not supposed to be. Remember, we only use the property of triangle or SOHCAHTOA to establish it. It is simply B/A. Okay, so if we want to even write something, it should be tan theta equals B/A for Z equals A plus BI. You understand? So don't write O/A because you are seeing it as a triangle, whereas it's not a triangle. We only use the idea.
Thank you.
You're welcome. And number 2, you said pi/3. How is that possible? Pi/3? Yeah. B/A should be minus 1/√3, Elsin.
Wait. Yes. Yeah.
Somebody's apartment, somebody's doing some construction.
It's mine.
Yeah. No. I'm just saying, like, I feel your pain is very annoying. You're trying to do something and someone is there. Oh, come on. Okay, question 3 from Kada has been seen. Perfect. You find your alpha. Good. Remember, something is missing. It's below the y-axis. So when you write your theta equals to, there should be minus bracket this fraction difference.
Right, that's my bad.
Yeah. You get what I mean?
Yeah.
Every other thing looks good. Okay, Miss Kells. There is no decimal point, Kelly. Arctan of 1 is not a decimal. There is no decimal. Let me try to find some scientific calculator online for Kelly.
Thank you.
Okay, so I'm going to share my screen with you. Miss Kels. Can you see my screen?
Yes.
So I just put scientific calculator. So I can just put rad. I believe this is radian measure. There is no way shift. Could this be inverse? You see, inverse. Inverse tan, right? Arctan of root 3. Root 3, for example. Let's see what that gives. You see that?
Oh, okay.
That's degree, but we don't need degree. So then you know, oh, you have to do 180, right? So that would be pi over 3, something like that. Okay. Let me, if I can see more, I will say.
You can press radian if you go up a little bit for this one.
Yeah, it's already. Oh, I thought I pressed radian already. It's going to give me decimal. I don't want decimal. I want it in form of pi. Because this has divided or like changing pi or something, pi over 3. It's like 3.143 divided by 3. That's why you have 1 point something. Understand?
Yeah, okay.
Okay, here's another one. Decimals. Let's see. If I put it on, this is radian. Yes. Where's the shift now? Clear. I'm trying to find the second function. Yeah. Okay, here is a function. Can you see?
Yes.
Arctan. So let's say minus 1 over root 3. Root is here. 3 is here. Close bracket. This bracket. Okay, the problem is it's giving me as that. This is degree. So I would suggest you work on degree, then you can change it to radian yourself.
Okay, cool.
All right.
Fine.
Good luck.
Thank you.
There's another one. Let me try this one. Root 3.
This one doesn't show fractions.
It looks what?
This one doesn't show fractions.
Yeah, unfortunately. So we don't want it. Get out of our way.
You don't see my argon diagrams because they're on the side a little bit. So
I would love to see it, sir.
Okay. It's in the next picture.
Okay. Okay. Checking colors work now. Okay, I've seen this already. Yeah.
I corrected a little bit.
Yeah, I've seen the correction. Carolina, I saw your question 3. Good. So you found alpha. Perfect. So your theta is pi minus alpha. So when you're writing that, Carolina, you say argument of z, which is theta, will be minus bracket pi minus alpha. Why do we need that minus? Because it's below the the y-axis.
Oh, okay.
All right, huh? So your answer will be the same, just there's a minus. So again, you write argument of z equals to theta equals to minus bracket pi minus alpha. Okay, then just go to the next line, equals to. You don't need to write argument of z again. So that will be equals to minus pi minus alpha is pi over 6. You substitute it, and then your last answer 5 over 6 pi or 5 pi over 6 in bracket radian. Good job.
Thank you.
I wrote something wrong. The 180 should be pi.
Yes, sir. Should be pi. And Elsin, you just put the diagram. You couldn't put any label stuff. Do you mind putting something?
I wrote it after. Sorry.
All right. So just take note of that. Yanko, I can see you've drawn the diagram now. Perfect. Yeah, that makes sense now.
Can I go grab a little bit of food? I'm a little bit hungry.
What? Yeah, of course. I have my stuff here too. So once I'm done talking, I'll start eating. Eating is not forbidden. Okay, Kelly. So 1 over root 3, you change it to root 3 over 3. Because it's not the final result, there's no need to rationalize. Understand?
Yes. Okay.
And your root 3 over 3 doesn't give you minus pi over 3. It is negative of 1 over root 3 that gives negative pi over 3. Okay? So the best thing you could do is to say, oh, tan of, maybe we can even introduce, okay, look at it this way, guys. Okay, so because we have to stop it here, it's already 11. I want us to wrap up everything by 11:15, okay? So that the last 5-10 minutes, if I need to explain something new, I quickly explain it. Otherwise, we'll look at it in class. I have the form 6 by 11:30, and their class is also going to be short because someone needs to go out, I think. All right, so everyone listen. So you all have the idea. You did a great job. The only thing is your presentation. Okay, that's the only minor error I've noticed in some of you. So for number 1, you draw the Argand diagram. Sorry, I can be OCD when it comes to drawing. You know, when you want everything to be perfect. It's not my fault. Because I don't want Carolina to make fun of me. Anyway, so the first looks like that. Luckily for us, our theta is also our alpha. So your theta is your alpha here, right? So you're welcome to find your alpha, then subtract, and then just say theta is equal to alpha. I think we should always call this acute angle alpha and also equals to theta. I'll tell you why in question 2. Okay, so maybe we can change the format a little bit to avoid any misconception. Now, the label I ask is this, that this is 1 and this is also 1. Agreed? Because I means 1i. So basically this is 1 plus 1i. All right, remember this is the imaginary axis. This is the real axis. So try and label properly. Now, having said that, then I can begin my workings by doing alpha. Say tan alpha. By the way, it's okay to do that. Tan alpha is 1 over 1, which means alpha is arctan of 1. So alpha is 45 degrees, and that is pi over 4. Then you can you can now conclude and say, oh, argument of z, which is theta. You know your theta is also alpha from the picture, right? Will just be pi over 4, and like Carolina did, rad in brackets. Understood? So let's work on alpha. The reason I said we work on alpha, you will see now. Question 2. If I draw the same picture, this time around, x is root 3, y is minus 1. So somewhere like this. Something like that. In this case, we could see clearly that this is our alpha and this is also our theta, right? So let's call it alpha. Okay, but this time around, our theta is negative. Okay, negative because it's below. So I just put alpha. in that bracket. Now, my theta is also this way. Sorry, I'm trying to, because this is my theta. So you see, I didn't say alpha is equal to theta because alpha is not going to be equal to theta. My theta will be negative the value of alpha. Am I making sense? So my theta will be negative the value of alpha. Theta is that angle alpha in opposite direction. Theta is meant to be going this way. Okay? So the fact that it's going to come this way means it's going to be negative. So if I come here and I write theta is equal to alpha, it means if my alpha, which is the acute angle, that acute angle is going to always be positive. Alpha will always be positive. Theta will only tell me, the negative in theta will only tell me the direction. Understood? Okay, so I just call that theta. So I could do the same here rather than say alpha is equal to theta here. I could do the same here and just say, if that is alpha, then my theta is this in this direction. So I don't have to equate them to avoid any misconception somewhere. So let's work out alpha. Again, we're going to do our label x and y axis. So this is √3, this is -1. So definitely this is -1 and this is √3, right? So when finding alpha, we are considering this triangle. This is 1. This is √3. That's the triangle we are considering. We don't have business with negative. Understood? So here we say tan alpha, opposite over adjacent. And alpha is arctan. You can use, I don't know why I keep mixing the lowercase and uppercase. It's okay to be consistent. So this is where I said you don't need to change it to √3/3. If your result in a question is 1/√3, in the final answer should be left as this. But we are not dealing with the final answer of any problem. This is just something that came in between a solution. So there's no need for all that. Okay, so in this case, I get my alpha to be, this is 30 degrees, and that is pi/6 in radian. Then I can say the arguments of this complex number, which is theta. From this picture, it is exactly the alpha in terms of size, but in terms of direction, it's opposite of the anti-clockwise movement. Then that is why you now put a minus before you write that. You see, there's no need to equate theta is equal to alpha or anywhere. Just find your alpha. In your conclusion, interpret whether you are copying the same value for alpha, whether you are subtracting from pi, whether you are including minus in your interpretation. Does it make sense?
Yes, but Mr. Daniel, for
Yes.
mine, I just went straight to alpha, and I still got the same answer, but the thing I did differently is when I looked for alpha, I just also put the negative in, and I got the same answers. That's still correct?
I know you will get the same answer. My point is, let's be consistent with the steps so that there will be no confusion. Because I remember in one of them, I had to tell someone, oh, there's need for minus somewhere. If we can follow this routine, there will be no need to maybe miss something out, if you get what I mean.
Yeah, okay.
Okay. That's why I said you have all done the right thing, but some of the mistakes that I pointed out could be avoided if we just follow one routine. And the routine henceforth is different from what I said in class. Now I see that we need to follow that routine. The routine henceforth will be find your alpha, which is always going to be positive. Okay? Then in your interpretation, introduce your theta. Then your theta will tell you from the picture what your alpha should be. Understand? Now, 3 is, I'm drawing 3 and 4 together. Minus, okay, -1 minus √3. So -1, which is here, the minus √3, which is here, something like this. So if you complete the picture, so this is -1, this is -√3, something like that. So the diagram we need here is going to look like this. Then you can see the arrow. The arrow tells you the direction. Are you with me? The last but not the least, 1 minus that. 1 is positive, minus that is, I thought we have done this. Oh, number 2. Oh, okay.
It's different.
Okay. What did I do wrong? 1.
The first one's positive, the fourth one's negative.
Oh no, both of them are the same quadrant, right? I'm trying to do this quadrant.
Yeah.
Yeah, okay. I'm going to change that question. I was trying to do this quadrant, okay?
Just add as number 5 then.
That would be what? X is negative, Y is positive. So it should have been minus 1, right?
Minus 1 plus I then.
Minus 1 plus I. Sorry about that. I tried to put question for the 4 quadrant, but it's okay. Just wait and see. So here, this is my theta, and this is the alpha. So we're going to have that. Again, it is minus what? Minus 1. So this is minus 1. Then this is also, this is 1 itself, not minus. Yes? Okay, because this is I. Okay, 1I. Understand? Now, is that Mr. Tamash? Say hello for me. So let's do the calculation now. Let's find our alpha. From here, tan alpha is root 3 over 1, which is root 3. So alpha is arctan of root 3. And that is 60 degrees, which is pi over 3. Can you see how I'm thinking about it, Kelly? Because I know it's going to be 60 degrees. Then I say, okay, what is 60 degrees in terms of pi? That is definitely 180 divided by 3. That is pi over 3. So I don't even need calculator. Okay. Now, from here, then I say argument of z, which is my theta. Looking at it, this is below the y-axis. I know it's going to be negative. Okay. Are you guys focusing now? Please listen. Looking at it, I know it's below the y-axis, then I put negative. The negative doesn't have to come in the calculation. Just do this first. Okay? Then also, then I know, oh, I have to subtract 180 minus the last answer to get the value itself. Then I say bracket pi minus pi over 6 over 3. You're free to write alpha first, like some of you did. That's okay. So this is the interpretation that you need to, that gives you minus, is that 2 pi?
Yes.
And that's it. Questions? And finally, here, let's change the color. Here we do our alpha again. Our alpha will be from this diagram. So this will be 1, 1. So tan alpha is 1 over 1. Alpha will be arctan of 1, which is 45 degrees. So that is pi over 4. Then my arguments, which is theta, it is on the positive y-axis. So it's going to be positive. But it is pi minus the alpha that I've obtained. So that's pi minus pi over 4. And that gives me 3 pi over 4 radian. Does this make sense? So let us follow this strictly henceforth. Then the issue of forgetting minus and all that will be a thing of the past if we can follow this strictly. Does this make sense, guys? Okay.
Yeah.
Yes.
Yeah. Mm-hmm.
Yep.
So with
Yep.
this, I can be assured that there will be no problem when I'm discussing polar form of complex number tomorrow. Okay, because I have the form 6 in the next 14 minutes, so I'm going to go now. Let me show you something before I go, so you have an idea what we are trying to do tomorrow. This is the polar form of a complex number. So a complex number Z, we can write it in this form. When I'm explaining, I like it when everybody please pays attention. So you see, the first thing we're going to do is to find the modulus of that complex number, then find the argument of the complex number and be able to write it in this form. I will explain better tomorrow. So polar argument form is called the polar, this is it, something like this. Okay, so we'll be discussing it tomorrow. So for example, this complex number can be written in this form. CIS means cos plus I sine theta, cos theta plus I sine theta. So you can say theta comes up again. That is why I needed you to understand this. And it's a good thing that we've spent maybe 30, 45 minutes now, so we don't have to go back to argument of complex number tomorrow. Okay, I will try to come up with some questions in the next couple of hours and send to you to just do self-practice. It's not going to be submitted work or anything. Okay, I'll send to you, just do self-practice on your own. Try to follow strictly the technique that we use on the board just now. Follow that strictly. You can avoid error. I know you have other ways of sorting it, but errors could come from calculation, errors could come from presentation. For example, somebody wrote maybe tan, I think tan alpha is 1/√3. Look at this. Alpha equals arctan of 1/√3. And the next thing I saw is minus pi/3. Elson and Carolina are not paying attention. And this is the problem I have with some of you. I'm discussing the error that I noticed somebody doing, and you are likely to make the same error if you do not listen to what I'm saying. Somebody wrote this. This is also very correct, but then this is the result. The reason is because this person can see clearly that the line is here. So he or she knows that the result should be negative, but it does not make sense from step 2 to step 3. How can you say the tangent of 1/√3 is a negative number? It's not. Even though this person is very correct, and these values are also correct because they are from the Argand diagram. Okay? But the presentation is like, it's like you speaking Cantonese in the wrong tone. Well, we know what you are saying, but you are not saying it correctly. So how can we avoid that? Let us solve the alpha part separately, and let's make sure the theta only comes in the last result when we are trying to interpret. And your interpretation will now be, oh, from the picture, I can see that my theta is facing the opposite direction. That is why there is need for negative. I can also see that, okay, like in this one now. Theta is facing the opposite direction. That's why you have this negative, because of the direction. Okay? Then, oh, I'm subtracting because this is a straight line and I have to subtract to get theta from this one. So it has nothing. There will be no judgment. No one is going to judge us for writing, oh, minus something and we are writing it wrongly. That's the whole point here. Okay, let's be consistent with this idea. Okay, this is where we call it a day. So let's say today is just to review argument. Then we will be better off next time, which is tomorrow when we meet. Any questions?
Not from me.
All right. Thank you for coming. I'll see you guys tomorrow in class.
See you tomorrow.
Tomorrow.
Bye-bye.